Good day, my dear students. Today we will open up another topic. Since you already know how to find the missing measurement of the right triangle and its application, the question is, what if it's not a right triangle? Do you know how to find its missing side or the missing measurement of the side? But before we go further with that, let us first investigate this triangle.
Investigate these 6 triangles. If you are asked to group the triangles into 2, how will you group them and what triangles are in each group? If we have to group them into 2, in group A, we have these 3 triangles. While in group B, we also have these 3 triangles. Obviously, we group them according to the emoticons drawn in the interior part of the triangles. Examine closely the triangles in group A. How about those in group B? Aside from the indicated emoticon, investigate the triangles in each group. Are there similarities with their angles? The answer is yes. In group A, all triangles that have angles that measures 90 degrees. Yet, they do have the same emoticon, the happy one. While in group B, all triangles have sad emoticon and also all of them have an angle that measures 90 degrees. How can you classify those triangles that have right angles and those triangles who do not have a right angle? In group A, those triangles are called oblique triangles in which they don't have a 90-degree angle. While in group B, those triangles are called right triangles. In previous lessons, you already knew how to solve for the missing sides in a right triangle using the mnemonics. So, for the sine, ka for the cosine, towa for the tangent, kao for the cotangent, sha for the secant, and cho for the cosecant. Now, just focus on the triangles in group A. Can you solve for the missing measurement of the side of these oblique triangles? If yes, then you can go directly to the practice part of this video. But if not, let's continue this video until the end. Oblique triangles, or those triangles don't have right angle, can be solved using the law of sine. Let us derive first how they came up with the formula for the law of sine. Consider the triangle below. Triangle ABC. The opposite side of angle A is denoted by small a, and the opposite side of angle B is denoted by small b, and the opposite side of angle C is denoted by small c. In deriving for the formula on the law of sine, we should follow certain steps in order to arrive for the certain formula of the law of sine. First step, using the triangle ABC, draw an altitude of the triangle from vertex C to side AB. Label the altitude as H. Using trigonometric ratios, form an equation that will solve A for the sine A and B for the sine B. So, we have sine A is equal to H over B because sine A or sine theta is equal to opposite over hypotenuse, and our opposite side of A is H and our hypotenuse is B, while sine B is equal to H over A. The opposite side of B is H and the hypotenuse is A. Step 3. Manipulating the equations obtained from sine A and sine B to find the equation or the expression that will solve for H, we have H equals B sine A by multiplication property of equality and h is equal to a sine b. Equating the both equations of h, we have b sine a is equal to a sine b since both are equal to h. Step 4. Dividing both sides of the equation by the product of a and b, we have copying the equation b sine a is equal to a sine b. Dividing both sides by ab, we have sine a over a is equal to sine b over b. Take note, this will be our equation number 1. Step 5. Using the triangle that was used in step 1, triangle ABC, drawing an altitude of a triangle from vertex A to side BC, we have the altitude labeled as H. Step 6. Using trigonometric ratios, let us form an equation that will solve for sine B and sine C. Using again the formula for sine theta of the right triangle, it is equal to opposite over hypotenuse. Therefore, sine B is equal to H over C and sine C is equal to H over B. Step 7. Manipulating the equations obtained to find the expression that will solve for H, we have H is equal to C sine B and H is equal to B sine C. Equating these two equations, we have C sine B is equal to B sine C since these two equations are equal to 8. Step 8. Dividing both sides of the equation by the product of B and C, copy the equation C sine B is equal to B sine C. Divide both sides by BC, we have sine B over B is equal to sine C over C. Take note of this equation. This will be our equation 2. So now we have already our equation 1 and equation 2. Using these two equations, using the transitive property of equality, therefore we can conclude that sine A over A is equal to sine C over C. So that will be our equation number 3. The law of sine is described by this relation. In any triangle ABC, sine A over A is equal to sine B over B is equal to sine C over C, or by using the ratio and proportion, it is also equal to A over sine A is equal to B over sine B is equal to C over sine C. So that is the law of sine. The law of sine is easy to follow and very useful in solving oblique triangles when you know the following information. 1. If the triangle contains two angles and one side. And second, if a triangle have two sides and an angle opposite one of these sides. We already have the formula for the law of sine. Then, we can easily find the missing measurement of any side of the oblique triangle. So, let's have this example number 1. Find the measurement of an angle B, the triangle shown below.
Number 1 illustrative example. So we have these triangles. Triangle ABC. Measure of angle A is unknown and measure of angle B is unknown. Angle C is given 67 degrees. Our side B is equal to 50 centimeter and our side C is equal to 70 centimeter. So we need to find the measure of angle B. What will be the measure of angle B? Side B is given, so we have this our solution. We will use the formula B over sine B is equal to C over sine C. So we have this given formula. Next thing to do, we need to substitute the values. Our B is 50 centimeter And then our angle B is what is asked. And our side C, it measures 70 centimeter. And then our angle C is equal to 67 degrees. Next thing to do, by using the cross multiplication, we have 50 centimeter sine 67 degrees is equal to 70 centimeter sine B. Then divide both sides by 70 centimeter. So what's left here is sine B. Sine B is equal to 50 sine 67 degrees over 70. So B is equal to arc sine 50 sine 67 degrees over 70. So our B is equal to,
Start.
so the measurement of angle B is equal to 41.11 degrees. So by using the law of sine, we have the answer for the measurement of angle B, which is 41.11 degrees.
Example number 2. Find the missing parts of triangle ABC below.
Illustrative example number 2, given triangle ABC, angle A is 42 degrees, angle B is 70 degrees, and side BC is equal to 6. So, what is missing measurement are 40 AB, AC, and angle C. So, in order for us to have an easiest access on how to find the two sides, we need to first find the measurement of angle C. So by using the angle sum theorem for the triangles, we have the total sum of the angles in a triangle is equal to 180 degrees. So we will have 180 degrees minus A minus B is equal to the measurement of angle C. So 180 degrees minus 42 degrees minus 70 degrees is equal to the measurement of angle C. So 180 minus 42 minus 70, we have 68 degrees. So that will be the measurement of our angle C. So we already have the measurement of angle C. So next thing to do, we need to choose if what side of these triangles will we need to find the measurement. So let's have the measurement of side AB. What formula will we use to find the measurement of side AB? So this one, the measurement of side C. So the formula we will use is sine over sine C is equal to, this is A over sine A. Okay, using the formula C over sine C is equal to A over sine A over there, we need to substitute the value of any of this side or of the triangle ABC. So our C is missing, so let's just copy over sine C, our angle C is 68 degrees is equal to, our A is 6 over sine 42 degrees. So by cross multiplication, C over sine 42 degrees is equal to 6 sine 68 degrees. So divide both sides by sine 42 degrees. Sine 42 degrees. So cancel. Remaining is C. So 6 sine 68 degrees over sine 42 degrees. Using the calculator, we have the measurement of our side C or side AB, 8.31. That is our AB. So we already have the measurement of our side AB. So next, we need to find the measurement of side AC, which is the side B. So we will use this formula. B over sine B is equal to A over sine A, or this here we can also use the C. So it's okay. We will have the same answer if we will use this or this here. So substitute values that are given. So our B, this is what we need to find, and then our angle B, sine 70 degrees, is equal to A is 6, and sine A, sine 42 degrees. So by cross multiplication, we have B sine 42 degrees is equal to 6 sine 70 degrees. Dividing both sides by sine 42 degrees, sine 42 degrees. So cancel. We have B is equal to 6 sine 70 degrees over sine 42 degrees. So by using the calculator, we have B is equal to 8.43. That is the measurement of our side AC. This one. So in triangle ABC, we have the answers for the measurement of side AB, side AC, and also for the angle C.
Example number 3. A surveyor wants to determine the distance across the river. He lays two posts in one side of the river 120 meters apart and another post on the other side. If the angle from the two posts to other is 45 degrees and 70 degrees respectively, how far are the posts from each other?
Okay, let's look at example number 3. A surveyor wants to determine the distance across the river. So this will be our river, assuming that this will be our river. So a surveyor wants to measure the distance across the river. He lays two posts in one side of the riverbank, denoted as X and Y, and then he also post another here in the opposite side, one post only, we have denoted as Z. So the angle in which these two lines intersect is 29 degrees and 51 degrees. So the question is, how far is this post to this post and this post to this post? So we already have this one, the measurement from this X and Y, this post. So we have 120 meters. So we need to find this measurement of this post. So what formula are we need to use? So since we have the measurement of the two angles, X and Y, so it's easy for us to know the measurement of this angle. So we have to use the triangle theorem, the sum of the angles in the triangle, which is 180 degrees. So the measurement of angle Z is equal to 180 degrees minus 29 degrees minus 51 degrees. So the measurement of our angle C is 180 degrees minus 29 degrees minus 51 degrees. So we have measure our angle Z is equal to 100 degrees. So we have already here 100 degrees. So we need to find the side opposite to angle Y, which is denoted by small letter Y, and X, the side opposite to angle X. So we will have to find first the measurement of this side XZ, which is denoted by Y. We will use this formula, XZ over sine Y is equal to XY over sine Z. So substituting the values given, we have xz. So xz is not defined. Y is, we have 51 degrees. Our xy is 120 meters and our z is equal to 100 degrees. So by cross multiplication, we have xz is sine 100 degrees is equal to 120 meters sine 51 degrees. So dividing both sides by sine 100 degrees so that the remaining is xz. So cancel, we have xz is equal to xz sine 100 degrees equals 120 meters sine 51 degrees. So divide both sides by sine 100 degrees. Sine 100 degrees here. So we have xz by using the calculator. We have 94.7 meters. That will be the measurement of our y, side y. Thing, we need to find the measure of side x or side zy. So we use this formula. Zy is over sine x is equal to xy over sine z. So substituting the values given, zy, this is what is asked, x, and over sine x, which is 29 degrees, is equal to xy. Our xy is 120 meters, and our z is sine 100 degrees. So by cross multiplication, we have x sine 100 degrees is equal to 120 meters sine 29 degrees. Divide both sides by sine 100 degrees. Sine 100 degrees. So we have x is equal to, so the value of our x using calculator, we have 59.07 meters. This is our side zy. So we got these answers, this, and also this one. So the post is 94.7 meters from x to point z, and from point y to point z, we have 59.07 meters.
Example number 4. Two fire lookout stations are 20 miles apart, with Station B directly east of Station A. Both stations spot a fire on a mountain to the north. The bearing from Station A to the fire is 50 degrees east of north. The bearing from Station B to the fire is 36 degrees west of north. Which do you think of the two fire trucks from two stations can arrive first to put off the fire?
Illustrative example number 4. So given there are two fire lookout stations, Station A and Station B. Both stations spot a fire from a mountain, assuming that this will be our mountain. So we have the fire here. So both stations spot a fire here, denoted by C. So the bearing from Station A to the fire is 60 degrees east of north. So we have northeast, so 50 degrees. And the bearing from Station B to the fire is 30 degrees west of north. So we have this west of north, 36 degrees. So the question is, which of the two stations where their fire trucks can put off the fire first in the mountain? Is it from fire trucks from Station A or fire trucks from Station B? So what is the first thing that we need to do? Since inside these triangles, we don't know the angles yet, right? So we need to find these angles, and these angles. First, what is this angle? So by finding these angles, we just have to subtract 50 degrees from 90 degrees. So 90 degrees minus 50 degrees is equal to 40 degrees. So we have station A, this is 40 degrees. In station B, so 90 degrees is equal 90 degrees minus 36 degrees. We have 54 degrees. So our station B or angle B, it is 54 degrees. Now, next thing to do, we already have the angles here, 40 and 54 degrees. We need to find the measurement of angle C. So, measurement of angle C is equal to, by angle sum theorem of the triangles, 180 degrees minus 40 degrees minus 54 degrees. So, the measurement of our angle C is equal to 86 degrees. So, we have this already, 86 degrees. So, next, we need to find the distance from station A to station. We need to find the distance, this distance from station A to the fire, and this distance also station B to the fire, which is denoted by A. So, first, let's find what is B. So we use this formula, B over sine B is equal to C over sine C. Substituting the formula B, this is what we need to find. Over sine, our B is 54 degrees, is equal to C, 20 miles, and our C is sine 86 degrees. So by cross multiplication, we have B sine 86 degrees is equal to 20 miles sine 54 degrees. So divide both sides by sine 86 degrees. Sine 86 degrees. Cancel. We have B. By using calculator, I got 16.22 miles. So therefore, the station A to the distance from station A to the fire is 16.22 miles. So 16.2. In order for us to know who will be the first one to arrive in order to put off the fire, we also need to find this distance from station B to the fire, which is denoted by C. So we use this formula, A over sine A is equal to C over sine C. Our A, this is what is asked, and our angle A is 40 degrees. Our C is 20 miles, and our angle C is 86 degrees. So by cross multiplication, we have A sine 86 degrees is equal to 20 miles sine 40 degrees. So dividing both sides by sine 86 degrees, this one also sine 86 degrees, cancel. So we have our A, 12.89 miles. So this is the distance from station B to station C. So the questions, who will arrive first in order to put off the fire in the mountain? Is it the fire truck from station A or fire truck from station B? So based on our findings, the distance from station A to fire is 16.22, while the distance from station B to the fire is 12.89. So who will arrive first? So therefore, the one that will arrive first is those who will travel less distance. So Our distance from station B to station C is 12.89. So, small distance. Therefore, fire truck from station B will arrive first to put off the fire in the mountain.
For now, you will have your practice exercise. You have to try this. Choose a partner in finding the answers of the problems that will follow. Answer it in a one-whole sheet of paper. Show your systematic solutions with illustrations. You can do it. Number 1. Find the measurement of side QR in the triangle below. Number 2. Two angles of a triangle measure 20 degrees and 65 degrees, and the longest side is 34 centimeters. Find the length of the shortest side. Number 3. Find the measure of angle YXZ and angle XZY in the triangle below. Number 4. An empty lot is in the shape of an isosceles triangle. The base fronts a road and has a length of 340 meters. If the legs meet the road at an angle 32 degrees, what are the dimensions of the triangular lot? Number 5. Cable wires are attached to the pole such that the angle of inclination at point A is 56 degrees. The distance between A and B is known to be 115 meters, and the angle formed when two cable wires are connected at the top of the pole is 54 degrees. Which cable wire has a longer length? Cable wire attaches from point A or cable wire attaches from point B? Assessment. Direction. Use the law of sine to find what is asked in the following problems. Show your complete solution. Write your answers and solutions in a one-whole sheet of paper. Number 1. Find the measurement of side QR in the triangle below. Number 2. A surveyor wants to determine the distance across the river. He lays two posts in one side of the river, 120 meters apart, and another post on the other side. If the angles from the two posts to other are 45 degrees and 70 degrees respectively, how far are the posts from each other? Number 3. A satellite orbiting the Earth passes directly at observation stations located at A and B. When the satellite is between two stations, the angle of elevation at A is 43 degrees and B is 33 degrees. How far is the satellite from point B if the distance between A and B is 810 miles? Number 4. Two hospital ambulances that are 13 miles apart are called simultaneously to rescue an accident with ambulance B directly east of ambulance B. The bearing of the accident from the ambulance A is 35 degrees east of north, and the bearing of the accident from ambulance B is 49 degrees west of north. Which hospital ambulance do you think will arrive late to rescue the victims of the accident? Verify your answer. Assignment. Directions. Read and analyze the word problems below. Answer what is asked. Show your complete solutions and write it in a one-whole sheet of paper. Assignment number 1. At a particular point, when an airplane was directly above a straight line road connecting two small towns, the angles of depression of these two towns were 10.2 degrees and 8.7 degrees. Find the straight line distances from the airplane to each of the towns at this instant, given that the towns are 8.45 kilometers apart. Illustrate. Assignment number 2. A satellite orbiting the Earth passes directly overhead at observation stations in Phoenix and Los Angeles, 340 miles apart. At an instant when the satellite is between these two stations, its angle of elevation is simultaneously observed 60 degrees at Phoenix and 75 degrees at Los Angeles. Which station is farther from the satellite? Is it Los Angeles or Phoenix? Why? I hope that you have learned a lot from my video presentation on the law of sine. Learning doesn't stop here as this video ends. Rather, you can answer more problems on your books or in other sources. Keep learning. That's all. Thank you.